Okay, everybody. So we're going to continue on with our SPDF idea. Okay, and again, we talked about prior to this, we talked about the hotel and how everything's positioned, and then the order of it with which you fill some of these elements. And just a couple more additions to this. I probably should have put this in the last video, but I figured I'd make a separate one here only because of the way this is presented. So, um, still thinking of this idea. There's rules that go along with this, and there's some scientists who dictated these rules, and I just want to cover some of that on those pages. So, if you look at the next video here, um, again, this is just a little bit of a chart on. It really shows you. If you look at the first energy level is going to have an S again, um, and again, you have to think of these orbitals as these boxes. Okay, so that's would be an orbital diagram. So again, this would have one box. Okay, and then you go and once you fill that, you go to the second energy level. Okay, which would have an S box, which have one orbital. A P would have this three boxes. Okay, spherical and dumbbell simply are the shapes of the orbitals. We'll get to that another day. But okay, and then you move on to the third, and again follows the one box versus three boxes versus five box idea. Okay, and so on. Okay, and then down here you'd have seven. Okay, before 5, 6, and 7. And again, 1 would hold 2, S always holds 2, P always holds 6, D always holds 10, and F always holds 14. So that's where you get the totals of 2, 8, 18, and 32. All right, so that's the idea. But just a quick thing in this video. This is not going to be a long one. It's just some ideas, some guidelines to doing this. And again, there's a number of scientists that worked on this, and I just want to make sure that you know basically the rules that we've been following and where those rules come from. So basically, the Aufbau principle really is electrons, and you want to write this down. Okay, electrons fill the lowest, okay, energy orbitals first. Okay, so that's really important. So its lowest energy is always first, and typically that's as close to the nucleus. So basically, we're always going to go. A good example would be, 1s before you go on to the next one, which is 2s. Okay, but you got to be careful. This is going to change a little bit. Again, you would if this is the nucleus and you have an electron there in the first row, because it's closer, you would choose the first energy level, and so you choose the first energy before you go to the second one, and so on, because it's further away. So electrons are always trying to get as close to the nucleus as they can, and spend time more close to the nucleus because they're attracted to. So again, you're going to fill the lowest energy orbitals first. Now, this might not be always in order as you think, but there's reasons for this, and I just want to just give you the main general idea. Okay. Hund's rule. Okay, again, these are all scientists that were part of this. Again, you don't have to know, exactly what every name is. It's just I want you to just be familiar with the rules here and where we get the rules from. Okay. And this one is in sublevels. Okay, with multiple orbitals. Now, what does that really mean? Again, sublevels are going to be with multiple orbitals, and this is again going to be your S, your P, your D. No, I'm sorry, it's not. It's going to be your PDF, not S. It's going to be P, D, or F. Remember, P is going to have your 3 boxes. I mean, these are multiple orbitals. Okay, D will have 5 boxes. Okay, 7 boxes. Okay, so sublevels are your SPD, is your PDF, right, with multiple orbitals. Okay, electrons will fill orbitals with a single electron before doubling up. Okay, and this is because of electron repulsion. Okay, so a good example of that is going to be a P3. So anytime you have a P3, we're going to have 3 boxes in P. Right? We're going to fill 1 box with each electron first, and then P4 would be a box, a box, and a box, and then you'd have 1, 2, 3, and 4. So we're always going to follow that rule when we do this. Okay, so to review it, in sublevels with multiple orbitals, okay, and that's going to be the P, the D, or the F, not the S. Remember, S only has 1 orbital, so you're going to fill those both. Okay, electrons will fill orbitals with a single electron, like this, before doubling up. Okay, so it's really important. Or another example is P2. If you have a P2, you would fill P2 with a 1 and a 2. Okay, if it's up to that level. All right. All right, cool. And there's one more left. Okay, and that's called the Pauli exclusion pill. Wolfgang Pauli came up with this idea. Okay, and the idea behind this one, again, one more real rule. Okay, is electrons occupying the same orbital. Okay, and again, an orbital is a box. Okay, must have opposite spins. Okay, and the scientists gave the word spin to this. I don't know if it's not that accurate. Electrons don't typically spin on an axis, but that's what they thought at the time, so the name kind of stuck. All right, so you're always going to treat electrons when you designate them as up and down arrows. Okay, you cannot have this. You can't have 2 ups and not 2 downs. And of course, the wrong answers a lot of times on tests will have these. You got to have an up down. Okay, really important that you have opposite spins. Okay, scientists realized that based on data, they found that electrons can actually occupy the same orbital, but only 2 can do this if they have opposite magnetic fields, all right, or opposite qualities to them in a way. Okay, all right. So to review, real quick, if I go back, okay, is again Aufbau principle, lowest energy orbitals first. Okay, Hund's rule, we're talking about multiple orbitals. You're fitting 1 at a time until you got to go back. Okay, and Pauli exclusion principle, 2 electrons per orbital. Okay, again, you're going to be following these rules anyway. I just want you to let you know where you got those rules from. Okay, and then we're in good shape. All right, thanks. Bye.